So this is the topic, leachate transportation and effect on soil properties. Actually, this study has been conducted during the period of 2008 and 8 to 2015. So it was about a case study on a waste dumping site, and then I have conducted a laboratory experiment and also waste that means leachate transportation modeling through visual mode flow software also that has been done. So these are the areas which I would like to share. So this is the organization of my presentation. I'll give a general introduction about the project and the, its relevance nowadays, and then I'll explain the case study I have conducted, then laboratory experiment modeling. Last one is the contaminant transport modeling. So, as we all know that the rate of population growth and urbanization is drastically high nowadays, and the population growth and rapid urbanization results in the consumption of more resources and generation of waste. So as per the available data, the municipal solid waste generated in urban India, it is more than about 55 million tons per year, and with about 5% yearly increase. About 94% of waste in India is seen to be disposed of unsafely, either burned in an uncontrolled manner, or it will be dumped in untreated landfills. So finding a suitable location for final disposal of the site, it's a major challenge for the municipal authorities nowadays while considering the municipal solid waste management. So if you're coming to the waste disposal techniques, the most common waste disposal technique is landfill technique. But in most of the cases, a properly designed landfill, it is not there. They'll simply dump without any treatment, or without any treatment to the ground or the surface of soil also. So the landfills, when we consider this landfill, it will generate leachate. As we know that leachate it is a water and water soluble compounds that accumulate as water moves through the landfill. So the contaminants present in the landfill leachate can be classified as hazardous conventional contaminants and non-conventional contaminants. So when we consider this classification, that is hazardous contaminants, conventional contaminants and non-conventional contaminants, these hazardous contaminants, according to United States Environmental Protection Agency, they have defined hazardous contaminants or hazardous waste. A waste is said to be hazardous only if the leachate generated from that waste consists of chemicals with a concentration 100 times that of drinking water standard. Then only that waste can be treated as hazardous waste. But when we consider conventional contaminants, it may include parameters such as total dissolved solids, hardness, alkalinity, that means chemicals such as chlorides, sulfate, iron, manganese, hydrogen sulfide, etc. But in most of the cases, normally that means usually we will find non-conventional contaminants in most of the landfill sites. So when we consider this non-conventional contaminants, they are largely organic chemicals that have not been defined and whose potential hazards to the public health and groundwater quality are not known. So 90 to 95% of organic chemicals in municipal landfill leachates are of unknown composition. And also the main thing is we cannot generalize the composition of leachate. For one particular site, it will be of it will be of a separate characteristic. when we consider nearby landfill, its leachate will show some other characteristics. It is very hard to generalize the character and composition of leachates. So, when we consider this untreated or damaged landfill that I have mentioned earlier, which was not the landfills, which was not a properly designed landfill, or when people are, that is, authorities are just dumping waste on a particular site which is not as per the standards, or after giving any protection to the ground or ground layers. So actually, by design, the risk of leachate generation can be mitigated only by properly designed and engineered landfill sites. Otherwise, definitely it will affect the soil characteristics and the structures, or that means if you're using that particular site for any other engineered purposes, definitely there will be its traces, and it will affect the soil and that structure, or whatever we are going to use that particular area, it will get affected. So in the case of an unlined landfill, the pollutants in soil remain in direct contact with the soil for a relatively longer period, and hence the nature of soil pollution differ from that of air or water pollution. So the unscientific management of municipal solid waste will lead to the contamination of soil, as we said earlier. The presence of pollutants in the soil can change the desirable engineering properties of the soil, and by detecting the leachate migration from the landfill to the surrounding soil, and by detecting the area which is affected, then only we can find control measures for reducing the effect on this soil. So if while placing the, as I said, while placing the new structures or new structures on the soil, the problems faced by the geotechnical engineers can be reduced by detecting the affected area, or how much that means area of what we say is contaminant zone. If we can detect the contaminant zone, then only the problems they face can be reduced. So when we consider the chemical composition of leachate, as I said, chemical composition of each municipal solid waste landfill site, the leachate generated from each landfill site will be different. So it depends upon age of the waste, then characteristics of the waste, and decomposition rate also. And also it will affect, when we consider the toxicity of leachate, these factors will have a great role on that means toxicity of the leachate from this particular site. So when this leachate migrate through surrounding soil, chemicals present in that is liable to the change of soil properties also. When we consider, so that was about the composition of leachate. Next is about the transportation pattern. I have already mentioned that after, if you are able to find able to determine the contaminant zone, that can be determined only by analyzing the transportation pattern of leachate through that particular area. So that also we cannot generalize. That also depends upon the ground profile, seasonal variation, precipitation rate at that particular site, subsurface condition, groundwater table, soil characteristics, etc. Next comes the effect on soil properties. We have analyzed the composition of leachate, its transportation pattern. Next is the effect of these leachate on the soil properties. So this effect on this soil properties by this leachate, it depends upon the concentration of chemicals. Concentration of chemicals definitely depends upon the composition of waste and the period of contact of these chemicals with the soil, and the type of soil also. Type of soil also will have a major effect on the soil properties. So if we can assess the impact of leachate on the engineering properties of soil, the problems that dealing with the contaminated soil by geotechnical engineers can be solved in a better way. Next comes to my study area. So to analyze these effects, that means to analyze the composition of waste, to analyze the transportation of pattern, and to analyze the effect of this leachate on the soil properties, I have conducted a field study first. For that, the area I have selected, it is at Kalamasheri, and this is the plan of that particular area. So we know that municipal solid waste, it is dumping site, it is marked here, and this red line indicates the national highway passing through that particular area, and railway line is passing there. Next comes a river, that means blue line indicates the tributary of Periyar also. So by analyzing this site, it is clear that only 3 sites are covered. That means one side it is river, one side it is highway, one side it is railway track. The accessibility is very difficult. To collect soil samples, it was a challenge for me. And then another thing about this particular study area, annual rainfall in this area, it was about 3,500 millimeter. And the region, it was an industrial area where several factories manufacturing chemicals, fertilizers, etc. was there. So we have expected waste, not only, that means municipal solid waste, we have expected these chemicals also in that area, that is based from the nearby small scale industries, we have expected. And the site it was spread over an area of 4 kilometers square, and huge heap of waste up to a height of 10 to 18 meter was there. And as I have said, the major boundaries, one is highway, National Highway 47, River Periyar, and railway track. So this was the photograph of my study area at that time. So as per the information obtained from the local bodies in late 90s, this was the major municipal waste disposal site of nearby municipalities and panchayats. So in 2008, at the period at which I have conducted this study, the waste dumping was approximately 50 ton per day. 50 ton per day. And the waste dumped at this site includes domestic waste containing kitchen waste, paper, plastic, glass, cupboards, etc. And the construction and demolition waste was there. Also, waste from poultry market, fish market, slaughterhouse, dairy farm, and non-infectious hospital waste was also dumped here. And the waste disposal was in an uncontrolled manner with respect to the frequency of deposition and quantity, and it was done without making any segregation also. You can see from the figure also, plastic waste was there. And the leaching of harmful chemicals and discharge of solid waste from the dump site leads to the pollution of Periyar River, and this particular site, they have stopped dumping. That means municipality have stopped dumping of waste in the year 2012-13. During that period, they have closed dumping of waste in this particular area. And this is the soil profile adopted for the study area. While talking about the soil profile, it was not possible to get an exact cross-section of the landfill site, that the area. So that means exact soil profile of the area, because it was about, I have already said, 10 to 18 meters height waste was dumped. And the typical subsoil profile and groundwater location was approximated from 3 boreholes. These 3 boreholes randomly spaced in the study area, and it was at a distance, a spacing of 10 meters. And the site was not equipped with any leachate collection system, and polluted soil, that means leachate affected soil, and the leachate from the base of the landfill, which was collected from these boreholes, which was made for the study purpose, and analysis was done on the sample, soil sample as well as water sample collected from these borehole as per the standard methods of examination of water and wastewater prescribed by American Public Health Association. And the chemical analysis of the soil sample as well as leachate sample was conducted at this Pollution Control Board, Kadavandra, Kochi. So after analyzing, this is the chemical characteristics obtained from the this chemical characteristics of leachate sample obtained from the boreholes. So you can see that borehole 1, borehole 2 and borehole 3, these are spaced at 10 meter lateral spacing, and these boreholes were taken up to a depth of 1.5 meter, because this water table was found within that depth. And this is the chemical characteristics of leachate samples, that means water sample collected from that boreholes. When we consider the chemical concentration of landfill soil, next is about the previous one, it was about the water sample. Next it is about the landfill soil chemical characteristics. So you can see that borehole 1 at 10 meter spacing. From that particular borehole itself, soil sample was collected from 3 depths at 50 centimeter spacing. So A indicates borehole depth at 0.5 meter, B indicates 1 meter, and C indicates 1.5 meter. Likewise, I have collected 9 samples from 3 boreholes. Okay, so these are the chemical parameters or chemical concentration of landfill soil, and this also same. So we can see that the parameters such as nitrate, copper, iron, lead, manganese, sulfate, etc. in the soil sample are within the allowable concentration. Means I'll show you the maximum allowable concentration of chemical constituents. You can see this table. This was based on the publication made by Illinois Environmental Protection Agency. So according to them, the maximum allowable concentration of chemical constituents in uncontaminated soil is within this range. Nitrates, chloride, etc. listed. So we can see that from the result obtained from soil collected from the landfill site. When we analyze that, we can see that nitrates, copper, iron, lead, manganese, sulfate, etc. within the allowable limit, and a slight variation is shown in is observed in chloride, chromium, cadmium, etc. But we can see that iron is showing a maximum concentration, and it was up to 15,000 926 milligram per kilogram of soil. So the reason may be when we consider the locality, it was an industrial. It was in an industrial belt, and there was number of small-scale industries. And based on these areas, these industries were also that means they were using this particular site for dumping waste from these industries, and they may have contributed a lot to for the higher result of iron. And this higher iron concentration may have reached the nearby soil and may have some effect on the soil properties. After analyzing the leachate sample, that means chemical characteristics of soil and water sample, I have analyzed the engineering properties of these soils collected from the boreholes. So these are the parameters analyzed, that means specific gravity, liquid limit, plasticity index, and permeability. So from that means the obtained 9 soil samples, I have analyzed the engineering properties also. So from the result obtained, that means from the result obtained, we can see that as the distance from landfill increased, that means as the distance from the landfill increases, we have observed that chemical concentrations, it is getting reduced. The liquid limit is getting increased. And when we consider the permeability or hydraulic permeability of the soil, it is getting decreased as the borehole distance increases. That means conductivity is increased due to the effect of soil. We can conclude like that. So the solid waste dumps have a significant effect on the engineering and chemical properties of soil. This was the initial conclusion I have made from the field study. So in order to confirm my observations, and I have conducted a laboratory study on the effect of leachate on soil properties, and to analyze the transportation pattern of leachate also. For that purpose, I have prepared a small-scale laboratory setup to simulate the leachate transport in an unlined municipal solid waste landfill on a homogeneous and isotropic soil. So for this, I have used a circular concrete tank of 1 meter diameter and 0.8 meter depth. And this tank was filled with soil to represent the area surrounding landfill. There was an overhead tank where the leachate was collected. Actually, I'll explain what was used in place of leachate. And from that overhead tank, it was supplied to the soil through a flexible pipe system where the rate of flow can be controlled. So this from the overhead leachate tank, this was supplied to a perforated container which was placed at the center part of the tank, and through the perforations, this leachate will get percolated to the soil. And the head of the leachate in the perforated container is made constant by an overflow arrangement. And the hydraulic gradient was maintained during the experiment, and it was in the range of 1 in 3.5 to 1 in 5.3. So this was my laboratory experiment setup. And again, for this experiment, I have used 2 soil samples. 2 tests were conducted with 2 different soil samples, and these test soils were filled in the concrete circular tank at a uniform density of 18 kilonewton per meter cube which is matching with the field density. At the center of the tank, above the filled soil, a circular container which was perforated, and it was of dimension 100 mm diameter and 150 mm depth, but it was kept in a pit of 80 mm depth only. And the perforations were made on the container to facilitate uniform passage of the leachate to the surrounding soil. And regarding the quantity of leachate, total quantity of leachate I have used, it was 9.5 liters. How it was calculated is, after passing the entire leachate to the soil, in the tank, we should obtain approximately 50% saturation. Such that I have calculated the quantity of leachate, and the rate of flow. It was decided to have this entire leachate to be transferred to the soil at a constant rate in 100 days. So by 100 days only, this 9.5 liter leachate will be transferred to the soil. And then so after 100 days, the leachate treated soil, that means soil which was affected with this leachate, was collected from two positions, which was at a radial distance of 200 millimeter and 400 millimeter from the point of application of leachate, that means from the center of tank. And also the samples were collected at two periods, that means immediately after stopping the passage of leachate, that is after 100 days, and also I have given another maturing period of 50 days. So after 150 days also I have collected soil sample, and tests were conducted on these soil samples collected. And how it was collected, we have used a PVC pipe of 100 mm diameter, and this was introduced to the required position, that was at 200 millimeter radial distance and one at 400 millimeter radius, and was taken out with minimum disturbance. And this was again separated into 4 samples at 150 millimeter depth, 300, 450 and 600 millimeter, and analyzed geotechnical properties of these samples. Next, about the leachate used. So I've already told that we cannot generalize the properties of leachate for every landfills, every municipal solid waste landfills. And again, these as these are organic chemicals and all, that will be of very unstable, and it may degrade in a short time, and it was difficult to store this field leachate also. What I have done is I have prepared a synthetic leachate, and synthetic leachate, by considering the quantity of leachate required, that was about 9.5 liters. And again, I have calculated for the leachate required for the further studies also. Based on that, synthetic leachate was prepared based on the chemical concentration of major ions, that is positive ions, cations and anions, in milligram per kilogram of soil. From the data obtained from that field, that means Kalamassery Municipal Solid Waste Dumping, data obtained from that particular soil was used for the preparation of synthetic leachate. The quantity of synthetic chemicals. So for preparing synthetic leachate, synthetic chemical compounds are to be added. So that was that its quantity has been calculated based on their molecular weight when it was mixed with distilled water and added to the soil. The ionic strength of the soil remains same. That was the criteria which I have followed. And to prevent the sedimentation of synthetic leachate, it was continuous supply was done in small quantities of solution to the experiment center. And the data obtained from the field, that was from Kalmasheri's area, it was tabulated soap. The chloride was found in the range of 2,500 to 10,500. Likewise, ammonia and other chemicals also. So, the criteria which I have followed is, after adding chemical compounds, I should get chemical concentration within this range. That was the idea. So the chemicals were selected such that the chemical compounds will give the desired result. So these were the chemicals used for the preparation of synthetic leachate, and the quantity used is also tabulated here. So after using these chemical compounds and after preparing the synthetic leachate, again its chemical composition was analyzed, and I have obtained the result within that range of values from the field leachate, yeah. So this the synthetic leachate, that was about the synthetic leachate. And next is about I have mentioned that I have used two test soils, and these were the test soils. One was of lateritic nature and other one was of clay nature. And initial properties of these test soils were also conducted. And this shows the particle size distribution curves of the test soils before treating it with leachate. And when we consider the engineering characteristics, it was showing specific gravity and density, everything like this. Liquid limit, unconfined compressive strength, and permeability was also tested. Next comes the chemical characteristics. Initial chemical characteristics of both the soils were also analyzed. Okay. Next comes the result obtained. That means I have tested these two soils after 100 days and after 150 days from two radial distances. Okay. So when we consider the results, these results were plotted such that test soil 1 and test soil 2. First figure shows test soil 1, second one it is of test soil 2, and then x-axis shows the depth of soil sample. Here we have collected soil at different 4 depths, that is 150 millimeter, 300, 450 and 600 millimeter, and at 2 radial distances of 200 millimeter and 400 millimeter. And this dotted line, that is of red color, it shows the variation of soil at 20 centimeter 20 centimeter radial distance, and the dashed line gives the result at 40 centimeter radial distance. And that continuous line, it is the value of control soil. So in this, from this particular result, we can see that the chloride concentration of test soil 1, it varies from 343 milligram per kilogram to 1500, and for test soil 2 it varies from 212 to 1303 milligram per kilogram. And the maximum concentration, we can see that the maximum concentration of chloride was observed at 0.3 meter depth and was at a radial distance of 0.2 meter from the point of application of leachate. While considering the maturing period, it was not showing a considerable variation due to the maturing period of 50 days. That means about 100 days result and 150 days was almost same. Similarly, I have plotted for each chemicals. For ammonia also we were getting the same, almost same trend. Nitrate, this shows the result of nitrate. Here it is of iron, manganese, zinc, nickel, chromium, so this was the result. So from these results, it is clear that the maximum percentage of chemical adsorption it is obtained at 0.3 meter depth and at a distance of radial distance of 0.2 meter. So as the horizontal hydraulic conductivity of soil it is less than vertical hydraulic conductivity, the flow is due to the gravitational force and the fast dissipation of leachate through the soil in the vertical direction compared to the horizontal direction. Also, when we consider the diffusion mechanism, we also have led to an increase in the contaminant zone also. This diffusive transport in soil, it is slower than diffusive transport in free solution because of the reduced cross-sectional area of flow. So we can conclude that due to the gravitational force and diffusive mechanism, the test soils at a depth of 0.3 meter will be highly influenced by chemicals in leachate than the other depths. Yeah. Now we have already found that maximum chemical concentration it was observed at 0.3 meter depth. So here I have plotted the concentration of all the chemicals at that particular depth, and it was found that percentage of different chemicals with respect to concentration of synthetic leachate at 0.3 meter and 0.2 meter radial distance from the point of application of leachate was shown here for both the test soils, test soil 1 and test soil 2. So we can see that the percentage of concentration of cadmium, copper, chromium, manganese, zinc, iron and nickel are very high, and all these chemicals belongs to heavy metal category also. So the effect of maturing period on chemical adsorption of test soil is plotted here, and it shows that for the test soil 1, there is only a marginal difference due to this maturing period of 50 days. 50 days will not be sufficient to give a good result also. And when we consider test soil 2, 50 days maturing period, there was a slight increase in the chemical concentration was observed, and this may be due to the difference in absorption and dispersion characteristics of chemicals at test soil 2. Okay, then I have analyzed the engineering properties. All these were chemical properties. When we consider engineering properties, as the synthetic leachate used for this particular test was of mixed contaminants or mixed chemicals, we couldn't identify the effect of each chemicals on the engineering properties. So what we have done is to generalize the effect of these chemicals on the soil properties or effect of these mixed contaminants on the engineering properties. This variation of engineering properties were plotted graphically with respect to total cation and total anion concentration. So from this figure for the test soil 1 and test soil 2, it is plotted, and the maximum difference in specific gravity it is observed at the position where cation and anion concentrations are maximum. And for test soil 1, specific gravity decreases from 2.64 to 2.47 after 100 days and further to 2.45 after 150 days. So a similar trend is observed in test soil. Here, the liquid limit is plotted. Liquid limit is plotted with respect to the spatial contours of ion concentration. This liquid limit is superimposed on the spatial contours. This was done for both the test soil 1 and test soil 2. This was done, and when we consider this, a slight increase in chemical concentration causes an increase in liquid limit of both the soils. And test soil 1, when cation anion concentration goes up to 4,500 milligram per kilogram to 400 milligram per kilogram, the liquid limit increases from 31 to 40%. But in the case of test soil 2, it increases from 50% to 55% at a cation anion concentration of 3,100 milligram per kilogram to 550 milligram per kilogram. Yeah, this is what I have just explained. In a similar way, I have plotted plastic limit also with respect to ion concentration, cation and anion concentration, plastic limit. Here we can see as anion concentration increases, plastic limit of the test soils decreases. And this shows the spatial contours of ion concentration superimposed with the plasticity index. Here also we can see that initially there is an increase in the plasticity index due to chemical concentration, and further increase in chemical concentration causes a gradual decrease in plasticity index of test soil. This is for test soil 2. This is for shrinkage limit. Shrinkage limit was observed to be decreased due to the chemical addition. Now, to analyze the strength of the soil, we have conducted unconfined compressive strength test, and it was observed that the presence of chemicals can improve the strength of soil. That was the result obtained from this experiment. And the cation concentration of some 6,100 milligram per kilogram and the anion concentration of 1,525 milligram per kilogram of test soil 1, UCC value increases up to 130 kilonewton per meter square from a lower value of 96.3 milligram kilonewton per meter square. And a similar trend is observed for test soil 2 also. So that was about the engineering properties, and for further analysis, I have conducted scanning electron micrograph tests on these soils, which was collected after 100 days only. So from these results, this is for test soil 2 and this is for test soil 1 SEM analysis result. And this shows that it is evident that municipal solid waste, landfill, leachate have a major influence on the soil properties. And test soil 1, it shows that an occurrence of grains of silt and fine sand fractions and little amount of clay asymmetrics between loose grains. It is shown so. And when we consider test soil 1 after 100 days, first figure it is initially, that means before application of leachate, and second is after 100 days of application of leachate. So after 100 days, test soil 1 was showing some crumbs of flocks with a porous nature. So we can say that the reaction of chemicals in the leachate with soil led to the flocculation of soil grains with large pore spaces between each flocks and is responsible for the increase in porosity of soil system. In the case of test soil 2, before leachate application, it indicates that it was of sheet-like structure, flaky arrangement of clayey particles, and after 100 days, it will the reaction products joining together and filling the pore spaces was observed. Okay. So based on this experimental study, it was found that the leachate was following a sloping downward pattern of flow through a uniform, dense and sinkled soil layer. But it is understood from the literature that variation in density, soil type, number of layers, presence of cracks, fissures, then direction of groundwater flow, etc. will have a major role in the flow direction and pattern of leachate through the soil. So since the site conditions of each landfill are different, the flow pattern of leachate through the landfill also cannot be generalized. The concentration of various chemicals will be different. The adsorption property of soil, mobility and solubility of chemicals, etc. will be different, and they will have a great influence on the retention of chemicals in the soil. So the chemical addition may disintegrate the soil grains, and this may cause reduction in the specific gravity and changes in the Attenborough limits, as well as flocculation of soil grains. So that was the conclusion of experimental study on the two test soils treated with leachate and also used for the analysis of leachate flow through a single layer uniform dense soil. And after that, the contaminant transport through the soil was studied using a numerical model of groundwater pollution transport, and that I'll discuss in this session. And here I have used visual mode flow program to model the study area. The area which was modeled here, it is the same area where I have conducted the initial study. The data which I have received from that study was used for this particular purpose. And the results obtained were compared with the actual value and the actual observed value to validate the test result. The elevations of this particular study area ranges from 12.5 meter to 2 meter above mean sea level, and this shows the surface contour map of the study area and the average soil profile obtained for this study area, which was prepared based on the borehole details in that field. and which was approximated based on the data obtained from that 3 boreholes. Okay. And this aquifer parameters were estimated from the data available in the local bodies, and the precipitation is the main source of groundwater recharge, and it takes place during the period of June to October. The groundwater recharge, it varies from 290 millimeter to 350 millimeter per year for an annual rainfall of 3,228 millimeter. The approximate hydraulic conductivity of field soil was varying from 0.002 millimeter to 7 meter per day as per the available details. And the conceptualization of the model was done using the following informations, that is the groundwater recharge. It was due to the rainfall from top of that aquifer, and about 9 to 11% of annual rainfall is considered as recharge, and the Periyar contributes and also receives groundwater from the aquifer system, and the area is functioning as landfill for 20 years, and after that the dumping of waste in that area was stopped. That means chemical input, or in this particular study, was for 20 years. After that, the chemical input was treated as zero. And the study area, it was approximately of 2,300 meter by 2,000 meter. It was simulated using a mesh of 80 rows and 80 columns, and the soil strata simulated in 3 layers with varying permeability in accordance with the adopted soil profile. You can see that in the picture. The vertical section along column number 38, passing through the waste dumping area, was selected, and it is shown here also. And the hydraulic conductivity of each layer, it was assumed as 4 into 10 raised to minus 7 meter per second. Second one, it was 1 into 10 raised to minus 6, and third one, it was 1 into 10 raised to minus 11 meter per second. The first stage of modeling of flow simulation for the computation of hydraulic head distribution was shown here. The flow, it was assumed as a steady state flow, and 10% of infiltration rate and recharge of 320 millimeter per year is fed into the model to simulate the aerially distributed recharge to the aquifer system. And here it shows the simulated groundwater contour and its flow direction also. When we consider the flow direction, it was towards the river, nearby river. Next, the model is calibrated between the observed data and the simulated result, and the water table configuration corresponding to September 2008 was adopted for this particular purpose. And for the steady state simulation, three observation wells were considered for calibration, and the predicted versus observed values of head was plotted, and it was observed to be of a reasonable accuracy. And in order to model the leachate transport, the flow of chloride concentration was simulated. Here, the mixed contaminants we couldn't use for this study, so I have selected chloride concentration for this particular study, and the chloride concentration at 3 observation levels during the same period was used for the calibration of solute transport also. The predicted and observed chloride concentration in these 3 observation wells for the steady state condition, it is plotted here. We can observe that it is almost same that predicted and measured chloride concentration was found to be almost same here. And while giving the chloride concentration input values, as per the information obtained from local bodies based on the quantity of waste dumped per day, it was calculated that for the first year, that means for 365 days, chloride concentration was approximately 1,500, and then 2,500, and last, that means during the 20th year, that period, that means during the closure time, it was 4,500 milligram per liter. After 20 years, as the waste dumping was stopped, then the input of chloride was considered as 0. So this was the input chloride concentration, and based on the input chloride concentration, I have analyzed, we have obtained the leachate concentration. Okay. So we can see a lateral spread of pollutant after 1 year. That means from the start of dumping period, dumping time initially. From the start of waste dumping, I have taken first year analysis. Okay, based on that, we can see that to a distance of 150 to 200 millimeter spread is found. That chloride concentration, it was found in a considerable concentration up to a distance of 150 to 200 meter. And the transportation of leachate, we can say that this is the trend of leachate transportation through the groundwater. Here it shows the vertical transportation of leachate after the same period, that is 1 year. That is, I have taken this along the same column, that is 38, which was passing through the dumping center of the dumping. Yeah. Okay. Next, this figure, it shows the same result after 4 years, after 16 years, and after 20 years. After 20 years means during the closure time. Also, I have taken observation after 1 year from the closure. That means after stopping the waste dumping, after 1 year, it is shown the fourth figure. 1 year after closure. So the same period, vertical dispersion of waste dumping taken for the same period. That means 4 years, after 4 years, 16 years, 20 years, and after 1 year, it is shown here. So it can be observed that the concentration of leachate around the landfill increases as time passes, and due to the addition of waste in the landfill, it is getting increased. Okay. So that increase, it is observed till the closure, or till the closure in the sense till the stoppage of waste dumping. After 1 year, it is observed that leachate plume is gradually shifted from the center of landfill area, and higher concentration points are shifted towards river. This is due to the influence of groundwater flow. So immediately after 1 year, we are getting a considerable change in the concentration of chemicals in soil. So for predicting the leachate concentration after 3 and 8 years, it was also done. I have predicted the leachate concentration after 3 years and 8 years. 8 years I have taken because after 8 years it was observed that the chloride concentration, it is it is very negligible in the soil. So this is the result. We can see the vertical dispersion also after 3 years of closure, after 8 years after closure. So here it shows that shifting of leachate is away from the source, and also the concentration decreases as can be observed from the color code. Color code, this concentration is getting considerably reduced, and even after closure of landfill, even though the input of volume of pollutants from the waste gets stopped, the trace of pollutant in the soil will continue for some period, but it will get diluted as the time passes. So this is, I have already said, this is due to the infiltration of surface water through the soil, and the concentration at the disposal place gets lowered to a very small value of 0.2 milligram per liter after 8 years. So in the period of this 8 years after closure, the effect of leachate on the dumping place will get nullified for this particular study area. We cannot generalize this result, it is for this particular study area. In order to generalize or to get the data for other sites, anywhere we can go with a similar study to be conducted to get the contaminants on, and to get the that means time required to nullify the effect of leachate on the soil properties. So I'd like to conclude my session with these major points. This was conducted, case study was conducted in a single municipal solid waste landfill area, which was not a treated landfill, not an engineered landfill. So the pollutants or contaminants or leachate, contaminants present in the leachate are free to flow as per the groundwater flow direction, and during the flow, this may get contacted with the soil and may affect the properties of chance for affecting the properties of soil. It is very high here. The major contaminants or major chemicals observed in this particular soil was ammonia, chloride, nitrate, iron, nickel, cadmium, chromium, etc. And the direction and pattern of leachate flow through the soil depends upon the type of soil, density of soil, layers of soil, cracks and fissures in the soil, groundwater flow, etc. So as the condition of each landfill site is different, flow pattern of leachate through the soil cannot be generalized. The adsorption property, mobility and solubility of adsorption property of soil and mobility and solubility of chemicals will influence the retention of chemicals in the soil also. And of course, the pore water fluid and its flow has a major role. So the contaminant transport through the soil is closely related to the contaminant transport through the groundwater flow. Okay, approximately 45% of concentration of chemicals present in the synthetic leachate was observed to be absorbed by the low compressible soil, and about 43% was absorbed by the high compressible soil. So this may be the range of absorption of soil, chemical absorption of soil. So from the output of modeling studies, the leachate plume was traveling a distance of 250 to 300 millimeter around the landfill area on a continuous disposal of 20 years. After 20 years, it has covered 250 to 300. In the first year itself, it has covered 150 to 200 meter area. Then in this site and in this waste disposal rate, it was there was influence area was not getting increased. Much increase was observed here. Maximum up to 300 meter was observed. So in the 20th year, maximum chemical concentration beneath the landfill, it was observed to be 4,500 milligram per liter. Further, it reduced to 700 within 1 year after the closure of landfill. So within a period of 8 years, it is getting nullified, or the concentration of leachate on the dumping place is concentration of chemicals in the leachate on the dumping place was found to be insignificant. So this study, by this study, it throws light on how the pollutants from a typical unlined municipal landfill transport through the soil and how it pollutes. It gets polluted. That soil is getting how it gets polluted. So the result of this study clearly establishes the influence of chemicals from the leachate of municipal solid-based landfill on the engineering properties of soil, and also possible control measures can be designed based on the result to reduce the extent of soil and groundwater pollution.